Continuing with factorization. Today we're going to learn how to factorize a difference of two squares. And then afterwards we'll learn how to do a difference of two cubes. So how do we factorize a difference of two squares? For us to be able to factorize the difference of two squares, we must first be able to identify it. So what is the difference of two squares? So let's see. Difference of two squares. Two squares. So a difference of two squares is an expression that has two terms with different signs and even exponents. We see an expression, we look at an expression and know it's a difference of two squares if it has two terms with different signs and all the exponents of the variables are even. So by even here we mean, for example, 2, 4, 6, 8, 10, and so on. Multiples of 2, in other words. So what are the examples? Let's take this for example. X squared minus y squared. This is a difference of two squares because we can see that there are two terms and they have different signs. This one is positive, this one is negative. And then lastly, we see that the exponents are multiples of 2 or are even. Let's take another example. X to the power 2 minus 25. This is a difference of two squares as well because it has two terms. One term is positive, one is negative, and the exponents of the variables are even. Let's take some more examples. 36a to the power 4 minus let's say 100 b squared. So this is a difference of two squares as well because it has two terms with different signs and the exponents are even. So I'm just gonna erase this and rewrite it to give me some space here. So 36a to the power 4 minus 100b to the power 2. And then last example. Let's say you have 144 minus y to the power 4. Now, this is a difference of two squares because you have two terms and they have different signs and the exponents of the variables are even. So that's how you identify a difference of two squares. Now, how do you factorize a difference of two squares? So once you've identified that an expression is a difference of two squares, how do you factorize it? And just to sort this out, I'm going to do it to write you factorizing a difference of two squares. So we're going to erase here. So to factorizing a difference of two squares. So to factorize a difference of two squares, first of all, step number 1, take square roots. Now when taking square roots, you are dividing the exponents. Divide exponents by 2. Exponents by 2. So when you look at the powers of the variables, to take their square roots is the same as taking the exponents and dividing them by 2. Right, that's step number 1. Step number 2, now that you have the square roots of both terms, you open 2 brackets. Open 2 pairs of parentheses. Right. So that is going to be this and that. So you have 2. And then we're going to erase this 2 and move them down here. So it was x squared minus y squared and x squared minus 25. So step number 3, in step number 3 we copy the original expression but replace each term by its square root. By its square root. By its square root. Right. In the first pair. In the first parenthesis. So in the first pair of parentheses, you're going to copy the original expression. However, you replace each term with its square root. Now, the last step, just trying to copy the expressions we have here since we are running out of space. So I'm going to erase this as well. The last step, which is step number 4, is the second parenthesis. Write the sum of the terms of the square roots, sorry, the sum of the square roots with both terms positive. With both terms positive in the second bracket, in the second parenthesis, second pair of parentheses. So in the second pair of parentheses, you are going to write the sum of the 2 square roots, making sure that both of them are positive. Right, and when taking square root of the terms, we always ignore the negative. Right, so let's go through the steps again. How you factorize a difference of 2 squares? You take square roots of the terms, which means for the variables you divide the exponents by 2. Then you open 2 pairs of parentheses. As you can see, we have 1, 2. Right? Then in the first pair of parentheses, you copy the original expression. However, you replace each term by its square root, which you have found in step 1. Then in the second pair of parentheses, you write the sum of the square roots, making sure that both of them are positive. So everything is positive in the second pair of parentheses. And in the first, everything looks like the original expression. So if the term was negative, its square root is also negative. Okay, So now that we have discussed, or rather we have stated the steps, let's take our examples again. So I'm going to erase these steps, but I'll mention them as I sort out the problem. Okay. So erasing. Now we are going to have what? Factorizing two squares. Difference of two squares. Let's just rewrite that again. Two squares. So let's take our examples again. We had x squared minus y squared. So here we had also x squared minus 25. Down here we will have 36a squared minus 100b squared. Well, a to the power 4, sorry. And then lastly we have 144 minus y to the power 4. So we're going to do them one by one. So let's follow the steps. Step 1, we take the square roots of the terms. So square root of x squared is the same as the square root of 1x squared. When you have the square root of a term there, you take the square root of the coefficient. There's a ghost 1 here. Square root of 1 is 1. So we're not going to write it because it's 1. X to the exponent 2, well, the square root of it, we divide the exponent by 2. This is what we mean by dividing the exponent by 2. And then we get x. And then the square root of y squared is equals to, well, square root of 1 is 1, because there's a ghost 1 next to the y squared. And the square root of y squared is y to the exponent 2 divided by 2. So that gives you y. Now, we do what? Our answer then is going to be equal to, open 2 brackets, or 2 pairs of parentheses. In the first one, we copy the original expression, but we replace each one by its square root. So instead of having x squared minus y squared, we're going to have x minus y, because this one is square root is x, this one is square root is y. So x minus y. In the second one, we add them. Make sure they are positive. Okay, so that is the answer. So you will never have a negative in the second bracket. Now let's go to the second one. Again, we follow the same steps. The square root of the terms, square root of x squared, square root of 1 is 1, of x squared is x to the power 2 divided by 2, which is x. Square root of 25 is equals to, we ignore the negative always. Then we get what? 5. Now that we have the square root, open 2 pairs of parentheses. In the first set, we copy the original expression, but we replace each term by its square root. So x squared here will be replaced with x. Then we have the minus from there, and the 25 will be replaced with 5. In the second bracket, we just add the square roots. Remember, the square roots are positive since we don't have a negative there when we take the square roots. Okay, so that is the answer then. If you want to see if this is correct, of course, you can multiply out using the FOIL method. All right, now going to the third one. On the third one, again, we're going to start by taking square roots. Square root of 36a to the power 4 is equals to 6a to the power 4 divided by 2, which is 6a squared. And then we have what? Square root of 100b squared. We ignore the negative. Is equals to 10b to the exponent 2 divided by 2. 10 because 10 times 10 is 100. 6 because 6 times 6 is 36. So that gives you 10b. That gives you 10b. And so we open now 2 pairs of parentheses once again. And what will we have? We write the original expression but replace each one by its square root. This one will be replaced by 6a squared. Then we have the minus. The 100b squared will be replaced by 10b. And then in the second bracket, it's the same roots, but we are adding them together. So everything should be positive in the second bracket. Okay, 10b. And so that is the answer. And then the last one, we want to do square root of 144, which is 12, because 12 times 12 is 144. And then square root of y to the power 4 It's the same as square root of 1 is 1. Square root of y to the power 4 is y to the 4 divided by 2, which is y squared. And then we have what? We open two pairs of parentheses. In the first one, we replace the 144 by the 12. Then we have the minus, because remember we're copying the original expression. Now this one, its square root is y squared. And then in the second bracket, we just add the square roots. Remember, they must all be positive in the one bracket. Okay, now in this case, even though we have factorized this by the difference of two squares, this one is still a difference of two squares. Okay, and if you check the other one, it's a sum of two squares. Now, for a sum of two squares, we can't factorize it in real factors. So we can just say we can't factorize it. So whenever you see a sum of two squares, just know you can't factorize it. Okay. Then when it comes to, well, in terms of real numbers, when it comes to 12 minus y squared, we can still factorize it. So when you have a problem, you can go on and factorize it. In this case, we would take the square root of 12, which is going to be, well, since well is not a perfect square, we are going to say, well, square root of 12 is what? It's 4 times 3, and that gives you 2, the square root of 3. Okay, because this one we can take square root of it, this one we can't. 4 times 12 is 3. We always find a square that will give us the number that we have here. If you don't know how to do this, you can just do it with the calculator. Then the square root of y squared is going to be what? We are going on because we saw this is still a difference of two squares. What we are doing now is factorizing fully, because at first we had factorized the original expression but not fully, because we can still factorize here. So this is going to be square root of 1 is 1, of y squared is y to the 2 divided by 2, which is y. And so the first bracket can be further factorized into, so here's the original, here's the other bracket that we can factorize, and this one will be what? 2 the square root of 3 minus y, because we are replacing this by its square root, which is 2 the square root of 3. We are replacing this by its square root, which is y. Then we get 2 the square root of 3 plus y. And so we have fully factorized. So the last one was just to make you aware that sometimes you will have to go further. So after factorizing an expression, then you must always check if you can't recognize any expressions in it that you can factorize further. So in this last one, we saw that after factorizing it for the first time, we still have an expression that is a difference of two squares, and therefore we can apply the method again to factorize it further. And that is how you factorize a difference of two squares. Right, see you in the next lesson.